Assalamualaikum warahmatullahi wabarakatuh. This is the explanation for question 3 of the mock Pspm Physics 2 Set 4 for week 15. Question 3 from chapter 3. This chapter contribute the highest mark allocation for Pspm question. The total mark are 12 questions. So now let's discuss how to answer these questions. 3A. A 5 ohm resistor is made from a wire with diameter, resistivity and temperature coefficient of resistivity are 0.274 mm, 4.9 times 10 to the power of negative 7 ohm meter, and 7.4 times 10 to the power of negative 5 per degree Celsius, respectively. Calculate the length of wire, the resistance, when the temperature of the wire increases from 20 degrees Celsius to 60 degrees Celsius. 3 marks. Okay, first, in order to calculate the length of the wire, first we have to calculate the area of the wire. So since we have been given the diameter, which is 0.274, so the radius is equal to the diameter divided by 2. Okay, so you will get the answer. Okay, so the area is equal to 5.9 times 10 to the power of negative 8 meters square. So this will give you 1 mark. Then to calculate the length, we use this formula. Length is equal to RA per rho. So substitute all the information. We'll get the value of length in SI unit meter. This will give you another mark. Next, the question asks you to calculate the resistance when the temperature of the wire increases from 20. So this is the initial temperature to 60 degrees Celsius. This is the final temperature. So we want to calculate the resistance. So we can use this formula. So resistance is equal to R0, which is 5 ohm is our R0. 1 plus alpha delta T. So delta T is the change in the temperature. T final tolak T initial. So you will get the answer with the correct unit ohms. This will give you another mark. So total mark is 3 marks. 3B. A cell has a terminal voltage of 1.35 volt when it is connected to a 0.9 ohm external resistor. So this is your V1 and this is your R1. When the resistance is increased to 2.4 ohms, the terminal voltage is 1.44 volt. Calculate the internal resistance of the cell. So here you have two different cases. When your V is 1.35, your R is 0.9. So you can use Ohm's law. V is equal to IR to calculate the current. For the first situation, V is 1.35, R is 0.9, we will get the first current. When V is 1.44 and R is 2.4, we will get the second current. The value of current is crucial because we want to use it in the next equation. So we have to use this equation in order to find the internal resistance. We use V is equal to EMF minus IR. So here, current for each voltage is different according to their value of resistance. So for the first situation, when V is 1.35, the current is 1.5. When V is 1.44 and the current is 0.6, the cell or the battery is the same. So we can solve these two equations simultaneously. Okay, so E is equal to 1.35 plus 1.5 R, and E is equal to 1.44 plus 0.6 R. So equation 1 is equal to equation 2. So 1.35 plus 1.5 R is equal to 1.44 plus 0.6 R. We can thus calculate the value of the internal resistance. So 1 mark for the equation and the other mark for the answer with the correct unit. So this will give you 3 marks. For question 3C, figure 3.1 shows a voltmeter with resistance 200 kilo ohms connected across a resistor Q. Determine the voltmeter reading. So here we have two resistance P and resistor Q connected in series, and the voltmeter is parallel to the resistor Q, and the voltmeter has a resistance of 200 kilo ohm. So here, in order to solve this equation, first we have to calculate the effective resistance. Okay, so we can use the value of effective resistance to get the value of the voltmeter reading, because we can see here we can apply the concept of potential divider, where V is equal to R total, R effective divided with R total times with the V total. Okay, so first we calculate the value of R effective. Okay, so 1 over 200 plus 1 over 100 will give you the value of the R effective, which is 66.67 times 10 to the power of 3 ohms. Okay, so you will get the R effective for RQ and also R of the voltmeter. Okay, so now we can use the potential divider equation. So R effective divided by R total. R total is 50 plus R effective, and V total is 40 volt. So we'll directly get the answer of the voltmeter reading across the resistor Q, 22.9 volt. Okay, 2 marks. Okay, so now we have the potentiometer. Figure 3.2 shows a potentiometer with a dry cell having internal resistance of 3.75 ohm. So ini adalah internal resistance R. When the switch is closed, okay, bila switch is closed, okay, the length AC is equal to 0.6 meter. Okay, when determine the equilibrium length when the switch is open. Okay, so now what we have to know is when switch is open, V across equilibrium length equals VAC will equal to the EMF of the battery. VAC is equal to the EMF when the switch is open. Okay, when the switch is closed, V across equilibrium, VAC is equal to V terminal. Okay, so to calculate, so we can use the relationship of VAC open over VAC close is equal to length AC open divided by length AC close. So VAC open is equal to the EMF divided by V terminal is equal to length AC open per 0.6. Okay, so EMF is equal to this formula lah. This is come from the formula of V is equal to EMF minus IR. Okay, so EMF is equal to I 15 plus 3.75 divided by V terminal. Okay, so EMF is equal to V plus IR. Okay, IR. Okay, so V is equal to IR plus IR, so that's why lah dapat I, R tambah R lah. Okay, so sini I, this is R besar, this is R kecil. Okay, that is the EMF. Untuk V terminal adalah is equal to I, R total. Okay, so kita akan dapat I dan juga 15. R total 15 untuk circuit yang secondary. So it's equal to length AC per 0.6. So you akan dapat nilai length. Okay, so dekat sini kita akan apply ratio. So ratio will give you 1 mark. And then kita akan dapat pengiraan jawapan length 0.75. You akan dapat another 1 mark. Alright, so that's it for chapter 3 or question 3, chapter 3.